All right. A function is said to be increasing if the tangent has a positive gradient. So think about it. If I've got a curve like this, positive gradient, we say that is increasing. And the y values are increasing as the x values are increasing. A function is said to be decreasing if its slope to the left has negative gradient. We say it's decreasing. This one we say it's increasing. Make sense? A function is said to be stationary if it has gradient 0. That means it is a horizontal line. So it's flat, it has gradient of 0, it's stationary. Make sense? In other words, we've got y dash greater than 0. If y dash is greater than 0, we say it is increasing. Why? Because y dash is gradient, the gradient is positive. If the gradient is positive, it is increasing. Y dash is less than 0, we say it is decreasing. Y dash equal to 0, we say it is stationary. You need to memorize that right now. Y dash is greater than 0. Never. Increasing. Less than 0. Increasing. Equal 0. Stationary. That's it. Simple. Let's do it. On the following graphs, indicate where the function is increasing, decreasing, or stationary. Well, let's start from the left. What are you going to say this is? Or up to here. Increasing until right there. What happens there? Stationary point. That's 0. And then 0 increasing. You're going to find your Year 12 topics a lot easier than your Year 11 topics. It's just the way it is. It's just the way the course is. I'll show you Year 3. Some of the top schools are average from Year 11. They're in the 30s. I'll show it to you, so you don't stress. Anyways, we'll leave it like that. Nice and easy. B, and we go again. Plus, 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 0, 0, negative, 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 0, and then obviously plus, 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 0, negative, 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 negative. Sounds good? Anyone have any problems? No? Makes sense. So, when something's increasing, what can you say? Y dash, let's keep that word. Y dash is greater than 0. But yes, you can say gradient, but we're going to more say y dash. Because y dash is gradient function. Your gradient is at a specific point, right? So, example 2. Show that y equals 5x plus 7 is increasing for all values of x. What's the key word there? Increasing. Increasing. What do you straight away write on top of it? Y dash, y dash. Don't get lazy. Y dash greater than 0. So therefore, y dash equals 5. And what do you know about 5? It's greater than 0. And then you make a little statement, right? Therefore, increasing. Literally just write this. Therefore, increasing for all x. B. Show that y equals x cubed is increasing for all values of x, apart from x equals 0, where it is stationary. Okay, let's have a look. Y dash equals 3x squared. What do we know about that? We know that's always greater than 0, except at 0, where it is actually equal to 0, which means it'll be stationary. And that's what you've literally got to write. Greater than 0 for all x except x equals 0, since at x equals 0, y dash equals 0, therefore stationary. Simple. Those two won't be in your exams. The third one will be. So that one, 100% will be in your exams. You guys understand when I say 100%, it's in your tests. You don't need to study more questions, just these, you've got to know them. For what value of x is this increasing? For what value of x is this increasing? Okay, so f dash of x equals 3x squared minus 6x minus 9. And what do we know about that? What's the key word again in this whole sentence? Increasing. So what must this be equivalent to? Okay, greater than 0, and then you'll start solving for that. Now it's up to you. You guys want to do it graphically? You want to do it the way I've shown you? You've got to pick what you're comfortable with by now. I'll divide everything by 3 because I can. And then I get x minus 3, x plus 1, x equals 3 and minus 1. I usually go and test minus 1 and 3. That's an open circle, test x equals 0. I get negative 9 in here, right, into f dash, not into the original, into f dash. I get negative 9. Is negative 9 bigger than 0? I would say no. Now I know the answer. X is less than negative 1. As long as x is smaller than negative 1 or x is bigger than 3, I will always have this function to be increasing. I mean, between there, it's probably going to be decreasing. That would be my conclusion. But anyways, any questions? Next one, I'll leave it as homework for us to look at next week. Something for you to think about. It's not that hard. That one's homework. Write it, HW, so you don't forget. All right. All right, we'll come back to this one. I want to come back to it because I've done it on Thursday and they did really well, and I know you guys will do it well as well. I'd rather finish off everything we need to finish and then I'll come back and do more on those ones. All right, stationary points and turning points. Okay, what's a stationary point again? What's equal to 0? There, we need to say those words. Because there's going to be a lot of things like, I don't know, next topic is going to be finance. I'm going to say something else also equal to 0. So a lot of things are going to be equal to 0, but you got to know which one. Okay, cool. Start point, y dash equals to 0. A stationary point and turning points are pretty much, for your knowledge, are going to be the same thing. They're just used interchangeably, but they are a little bit different. But like I said, for your knowledge, they're going to be essentially the same. So find the stationary points of the following functions. How do we find stationary points? Stat points, underline it, y dash equals 0. I like to write it like this is because by the time you're going to write it in your HSC, I did say it's about 8 marks, which means there's going to be a lot of working out you're going to have. You don't want to mix it and miss anything. So we'll keep things nice and tidy. Stat points, y dash equals 0. Y dash equals 3x squared minus 6x equals 0. I can see I can factorize a 3x, x minus 2. So therefore x equals 0 and x equals 2. Okay, what's the key word in this sentence here now that I haven't technically used? So, what's the key word in that sentence there?
Points, so we have to find the ordinates as well.
I like that. Points. A point is what? An x and a y. Yeah? So I've only found x. What are you going to do to find y? Sub it back in. So 0 take away 0 is 0. 2 cubed is 8. 8 take away 4, 3, 4, 12, negative 4. Don't do it in your head, please. Don't do it in your head. Use your calculator. We don't want to make mistakes. No room for silly mistakes. Now, you're in year 12. When I was in year 12, 1 times 0, I would plug it into my calculator because I'm trying to think of stationary points. I'm not thinking of 2 times 3 times 4 times 7. I'm not doing that. No mistakes. Okay, done. Easy. 100% will be in your exams. 100% will be worth, just stationary points is worth 2 marks. So you're already 2% of your HSC. Yay. Next one. B. Let's do it. If you guys got no questions, I'm just going to keep moving. Y dash equals 4x cubed minus 16x equals to 0 for stat points. Factorize 4x out, x squared minus 4. And what do you get? X equals?
Minus 2, 2.
And?
0.
0. Good. 0, x equals 2. And if you do your working out the way I'm showing it to you, then it's nice and neat, right? Look how I didn't write plus minus 2. I wrote x equals 0, x equals 2, and then I'm going to write my y values just underneath. Just, I don't know, I feel like it just looks neater. Things make more sense. You can see it a little bit easier. Y equals, where do I sub in 0? The original. I'm going to keep emphasizing that because we're going to be subbing it in eventually into y dash and y double dash, and that gets confusing because everyone looks at it as a y, but it's not. One's a y, one's a y dash, the other one's called y double dash. So, but yeah, sub back into the original. You get 0. This one you get 16, take away 32, negative 16. This one you get, I think, the same. Thank you. All good? So stationary points, we can say it's done. I'll do this last one, whatever. There's nothing to it. X equals 0, y equals? Oh, just to get it out of the way. Stat points, when do they occur?
Y dash equals 0.
Increasing,
Y dash greater than 0.
decreasing.
Y dash smaller than 0.
Good. The question now arises, what type of stationary points do we have? We actually have 3 possibilities, technically, because these two are the same. They just change direction. But anyways, there's 4 possibilities. So you've got a maximum turning point, true, or maximum stationary point. You've got a minimum stationary point. And then you've got what is called a horizontal point of inflection. Horizontal point of inflection. Have you seen them before? Cubics, squigglies. Remember those guys? They are horizontal points of inflection. Okay? Let's do it. I can complete that, but again, I'm about to do it here anyways. You're going to see a little bit better through a question. So let's just go to example 5. Find the stationary points of, and then determine their nature and sketch this function. Who wants to take a guess of how many marks this is?
3.
It's actually 6 marks. 2 marks for stat points, 2 marks for nature, 2 marks for sketching. Cool? Yep. Very, very good marks. That's why I said most students eventually get this. It's not that hard of a math concept, I guess. The nature we're talking about is that whole min-max or horizontal point of inflection or something. All right, let's start. Again, keep things nice and neat. Stat points, underline it. Y dash equals 0. So y dash equals 3x squared minus 3 equals 0. X equals, just by looking at it, 1 and negative 1. Good work. Y equals 1 take away 3, negative 2, negative 1 plus 3, 2. You're checking it, right? Thank you. Done. 2 marks. Now we need nature. Nature, obviously because at the beginning of the booklet, I'm only meant to be doing it the first way, but I'm not going to do that. I'm going to show you both methods right now. So there's 2 methods. One method is more superior than the other method. One method doesn't work all the time, though. So either method have flaws. So one method's slow, which means you're not going to do it all the time. The other method's faster, but the method that is faster has some restrictions sometimes that you just can't, you don't want to do it. So you have to go back to the first method. We might not have that problem this year. We might have a problem next year when we start doing logs and stuff, because we're going to do exactly this, stationary point, for exponential, for log, for trig. That's it. That's pretty much what your talk's going to be about. You're going to be doing this concept over and over again. So it's not hard, it's just that maybe the second method might be not the best thing to do. Anyways, nature, you don't do both methods, right? We're going to do both methods, but in your exam you only need to pick the one. Cool? But we're going to try to do both until you guys say, I like this method more, and then we'll just stick to that. Let's do it. Nature. Method 1. Method 1. It's called the Y- table. So method 1 is the Y- table. Just before I continue this, I don't need to say you guys are in year 12 now. By now you have to realize which method you want to pick, which teacher you want to really pick and listen to. You don't really have time anymore to mix and match between me and your teachers. That's all I can say. But please don't choose the wrong one now that you're in year 12. Method 1, Y- table. All right, here we go. We've got 2 points. We're going to say at 1 and -2. Here's my Y- table. It's a Y- table, so that means it's going to be X and Y dash. The middle component is 1. Obviously, X is 1. What does Y- equal to when X is 1? What does Y- equal to when X is 1? Anyone? Any ideas?
0.
0. Y- is equal to 0, isn't it what you solved? Y- equals to 0 when X is 1. Y is -2. Now, so that means the middle term is always going to be 0. Always. No matter what question you're going to do, it's always going to be 0. Then you choose a number before, you choose a number after. Now these numbers should be very close to 1. So sometimes it's better to choose 0.9 and 1.1. Again, maybe not for these functions, but for exponentials and trig functions, you don't want to go too far because things oscillate and they're very close together. All good. And then what do you think you're going to sub in 0 into what? Into Y-. See how important it is? Not Y, that's Y. That's Y-. So we're going to sub in 0 into here. What do you get? -3, sub in 2. 4 times 3 is 12. 12 take away 3 is 9. All right, and we'll do it again. At -1 and 2. So that's not that hard, is it? Again, there's your X, there's your Y-. Just getting your hands used to this. X is -1. What does Y- equal to when X is -1? 0. And then again, choose a number before it, choose a number after it. At -2, sub it in. It looks like it's 9. At 0, sub it in. It gives you -3. All right, I'll pause there. Anyone have any questions? Easy. Okay, let's recap something. When Y- was less than 0, what did we say? Decreasing, which means the gradient is sloped to the left. So if Y- is negative, don't remember the number, it's negative, it's sloped to the left. When Y- is equal to 0, it's flat. When Y- is positive, it's sloped to the, what do you have? A min or max? Min. Make sense? 100%? Then the next one, if it's sloped to the right, so Y- is sloped to the right, so that's sloped to the right. Y- is equal to 0. Y- is sloped to the left. So what would it be at this point? A max. And do you see that happening? Yeah. Anyone have any questions? That's method 1. So not that hard, really. It's just more about substitution. So, but again, it's annoying when the equation takes up this whole line. If the equation took up a whole line, you want to sub that in. Oh, it's a mess. And that happens for those 9900 questions. So maybe you might not want to do method 1. You might want to do method 2. Method 2 is what is called y double dash method. So method 2. Y double dash. It's never going to tell you which one to choose. You're meant to pick whatever you want for nature. Y double dash. Okay. 2 things you do need to know before we do it. If y double dash is greater than 0, I know your brain might think it's a max, but it's not like that. Greater than 0 is the opposite. So therefore it's a min. And then y double dash less than 0 is a max. So y dash greater than 0, increasing. Y double dash greater than 0, minimum. You can't mix the two. Because on Thursday I was hearing y dash greater than 0, oh, it's a minimum. It's not like that. You've got to be very strict with that. Y dash is increasing, decreasing. Those are the words. Full stop. Y double dash, minimum, maximums. Okay, and that's really it. We're going to do y double dash. So if y dash was 3x squared, take away 3. Y double dash is, what did I say, 3x squared, so 6x. And then you do the same thing. At 1 and negative 2, y double dash equals 6x. X is 1. What does that become? Yep, 6, which is greater than 0. Then you write min. I want to see it like that. If I see a sentence that isn't like that, again, I know you haven't been doing it my way, you've learned it your teacher's way. I know straight away, right? Because I do things very particularly, in a particular way. So, at negative 1, comma 2, y double dash equals 6x, which equals negative 6, less than 0, max. And you're done. So that one's a little bit easier because you can see there's not too much to substitute. When do you think that's going to be annoying? Method 2 is going to be annoying when it was already hard to get the first derivative, let alone you've got to differentiate again, right? Again, these ones are easy. What if I gave you something that has a quotient rule, product rule, and a chain rule all together, and that was already long enough to do y dash? You know, you don't want to do y double dash. You might as well just do the y dash table, sub it in. So that's when I said it's going to have a flaw, and that's the flaw. The flaw is just, it's not that it won't work all the time, it's just that it might be a bit annoying to do. You have to sketch still when I'm done. Sketch. So let's recap real quick. Question said find stationary points and nature. Stat points, y dash equals 0, done. Nature, 2 methods, y dash table, y double dash technique. So y dash table, you go at this point, you got to talk to us, otherwise we won't know what table you're doing. That's why I go at this one. This is x and y dash. You choose 1 and your gradient is 0 there. Choose one number before, choose one number after. So you realize before it, the gradient is negative. The number after it is positive. That means it must have been a minimum stationary point. Same thing here. You realize it became a maximum stationary point. Or you do the y double dash technique where you've got to memorize this. Greater than 0, like I said, your head might think max. Just remember it's always opposite. So min. Minimum less than 0 is a max. And then all you're going to do is sub it in and realize the number is greater than 0, minimum, less than 0, maximum. And sketch. Let's sketch this guy. Finally, what is it? X cubed minus 3x. Here it is. What was our points? 1 and negative 2. 1, negative 2, and negative 1, and positive 2. It's a maximum here. It's a minimum here. Where is it cutting? The intercepting. You know, when you sub in x equals 0, you're going to get y equals 0. That's obviously intercepting at 0. I think we all know how this is going to look like, yeah? So the thing you didn't have before were those turning points. In polynomials, when you guys were doing this, you had to actually work out these points. Using polynomial division, blah, blah, blah. Now you don't need to do that anymore because you've got its turning points. Once you've got its turning points, you can draw the graph. And intercepts, I guess. If you've got your y-intercept, it's good. It's done. Any questions? 6 marks. We'll do it again. No harm. No harm. Let's make a quick point here. Y double dash greater than 0 is a minimum. Less than 0 is a maximum. There is obviously equal to 0. Right? And we'll talk about that in a second as well. So if you do get equal to 0, because I think it might happen with this one, no dramas. I'll tell you what you're going to write and then we'll learn how to fix that. All right, I'll give you guys just a minute to start it off. Maybe start your stationary points, work on your nature. Let me start as well, so you can double check it. Find stat points. Stat points. Y dash equals 0. So 15 x to the power 4 minus 60 x squared equals 0. I would probably factorize an x squared and maybe even 15. And then you're left with x squared take away 4. Is that right? X equals 0, x equals 2, x equals negative 2. Yep. What'd you get for y values, Novak?
Negative 64.
So negative 64 for the positive case?
Yes.
Done. Okay, I mean you're done. That's 2 points. You've got to determine their nature. What does nature mean? If it's a minimum or a maximum. So, we go to nature. What method do you guys want me to pick? You want to do both or you want to do one? It's up to you. Just do both again? Or pick one of them? Well, see there's 3 of them. You've got to understand that there's going to be 3, you're going to have 3 y dash tables. It gets a bit annoying. I think we'll try y double dash and I'm going to show you what problem you might face with one of them, because I can see it. And then what you have to write, and so on. All right, let's do it. Nature, we'll do the y double dash technique. Y double dash. Y double dash is 60 x cubed minus 120 x. Then we go at 0, 0. What do we get for y double dash? At 0, 0, you'll get 0, which is interesting. At 2, you'll get 240, which means what? Greater than 0, it's a min. So So that one's done. At negative 2, you get negative 240, which is less than 0, which is a max. So if you ever get y double dash equal to 0 at this stage, at nature, the only conclusion you can make is possible point of inflection. We're going to talk about that in our third step. Has anyone heard of a point of inflection before? Yeah? No? Never? No?
Yeah.
Oh, yep. Anouk, you want to tell us quickly what it is from your own knowledge?
Oh, it's what happens at 0 to execute the graph. So the graph sort of changes direction but keeps heading off in the same direction. It's kind of weird.
No, you can't, I can't accept that definition. It is the point where it changes from A. Do you want to continue it now, Anouk? Not sure? It is the point where it changes from a maximum to a minimum. That's what I meant by the cubic. So isn't there something that usually changes all of a sudden? It moves from a happy to a sad, or a sad to a happy? There's going to be something that happened. That point is called the point of inflection. I'm going to show it, but I'm just saying that's all we can conclude at this stage. Cool. Now, if we didn't do the y double dash technique, and we did the y dash technique for just that one, because that was the only one that had a little problem at this stage, since we haven't done the third thing yet, which is called points of inflections, we're going to go back for this one, and we're going to do the y dash table. So if you ever realize you have a problem, and the question didn't have points of inflections, but your questions will, because you're going to have an exam, and your exams will have the whole topic. We're teaching this as you haven't done points of inflections yet. So you'll do the y dash table. X, y dash. There's 0, there's negative 1, there's positive 1, there's 0. Sub in negative 1 into where? Into y dash. That's why it's y dash table. All right, so y dash is here. You get 15, take away 60, which is negative 45. Again, 15 take away negative, what? Negative 0, negative? That looks familiar, doesn't it though? Isn't that horizontal point of inflection business? Remember that? Let me scroll up, just so you guys can see it again. Remember? There was this one, maximum turning points, minimum turning points, and then there's these two. Okay? Now, it's not always necessarily true where you get a negative, 0 and a negative, where it becomes a horizontal point of inflection. The reason why it's not necessarily true is because to prove it's a point of inflection, you must do the third step, which we haven't even got to yet. But for now, at your stage, we're going to assume it's true. So the graph becomes this. What is it? Yeah. 2, and negative 64. It's a minimum at negative 2 and 64. It's a maximum and then a horizontal point of inflection. So you ready? So it looks similar to the one we did above. With the one above, we just cut through. This one here, I've got the squiggly happening in the middle. That's the only difference. Sounds good? From your polynomials knowledge, you know this makes sense because that's a power of 3, right? A cubic, that's a power of 3, 4, 5. So there's 5 intercepts. True? 3, one more time, 3, 4, 5 intercepts, or 5 roots. Look at that. The polynomial had 5 roots. Well, it has to have 5 roots. All right, enough with that. Let's keep moving. Find the second derivative. I think I'll leave that. We'll just call it homework. It'll take you 2 seconds. All right, we've already spoken about this. but we'll read it again. If y double dash is greater than 0, it is a min. If y double dash is less than 0, it's a max. If y double dash equals to 0, the nature of this point is inconclusive. So in this instance, we have to find its nature, and you're about to see that in a second. And that's what I mean by inconclusive. So what do we have to write? If you're at the nature stage, let's get it clear. If you're at this stage, the only conclusion you can make is possible point of inflection. You're not allowed to say it is a point of inflection. Why? Because of points of inflections, you must prove them. You're about to see what that is in a second. Oh, easy. Move on. Find all stationary and determine their nature using the second derivative. Well, we've just done that. So can I say we skip it and have a quick read again? Find all stat points and do their nature using the second derivative. We've literally been doing that because I did both methods anyway. So we'll leave that one as homework as well. And we'll leave that one for homework as well. We'll probably finish it today, these homework questions. It'll be our classwork anyways. While I don't forget, let me print the other one as well. We'll do one exercise a week. I don't think it's going to be like 15,000 questions. Second derivative, and don't prioritize your teacher's work. Don't prioritize your teacher's work, please. No more. You're in 12 now. You got to get my work done. Doesn't matter. Second derivative. So what is a point of inflection? You ready? This we said was increasing. That's the words we used. This we said is stationary. That was the word we used. Here we said it was decreasing, but there has to be a point somewhere here that it changed from a sad to a happy. And that is called a point of inflection. POI, I just call it. So now we know what a point of inflection is. It's a point. The best definition you can give is it's a point that changes your concavity from a minimum to a maximum or vice versa. That's it. Or you can just say concavity. I think everybody understands concave up and concave down. So again, you know, this is decreasing, whatever, stationary, increasing, 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 increasing. And then what happened? It's still increasing, but doesn't that look like that was happy and all of a sudden it's changing concavity? So what happened? There must be what? There must be another point of inflection, and I think it's probably just there. That's another point of inflection. Just look at it one more time. Sad, happy, and then starting sad again. And then what's happening here again? Another one. There we go. So that is sad, 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 until probably just there. And then it's starting to become happy again. These are what's called points of inflections. Points of inflection. This one was specifically called it was a H in front of it, I said. Horizontal point of inflection. So be careful. There's two types of points of inflections. There's your normal ones that you're used to from sad to happy. And then there's these ones that are the squiggly ones. The squiggly ones are called horizontal points of inflections. You want to write a note of that, whatever you've got to do. Let's move on. All right, let's check on the boys. Anouk, Andy, all good?
Yeah.
All right.
Yeah.
Done. Show that 0, 0 is an inflection point. Yeah, I'd rather just get to this. Find all critical points and determine their nature. Let's just smash the whole thing out. That's everything. So, how do we find a point of inflection? A point of inflection is found by, anyone take a guess?
Y double dash equals 0.
Yeah, because you had y double dash greater than 0, right? We said y double dash, don't write this yet. We said y double dash greater than 0 was a min. Y double dash less than 0 we said is a max. That means at y double dash equals to 0, just in between them, had to be your point of inflection, where it isn't a min or a max. Same thing with this guy, right? Look, y dash greater than 0, we said it's increasing. Y dash less than 0, we said it's decreasing. Well, then that means that y dash equals 0. It's not increasing or decreasing. It is stationary. But don't mix the two up, right? You need to know which one's y dash, which one's y double dash. Rub it out. I'm about to show you how I pretty much want this question done. All questions. So now, as we're finishing off this topic, because this is the last bit of it, actually, done. It's going to be set out like that. So we're going to set it out like that as well. So y dash, y double dash. Then we're going to have stat points. So you're going to underline it. You're going to have y dash equals 0. Then after you're working out, you should have somewhere here nature. You're going to do whatever technique you want, y dash table or y double dash. The last bit is you're going to do points of inflections. How do we find point of inflections? Y double dash equal to 0, and then technically we should be done. We can sketch the curve, and that's your 8 to 10 marks that I was talking about in your HSC. Let's start from the top. This question, the only difference is it does say critical points. What's another critical point that obviously calculus isn't taken into account? What are the other critical points in your graph, usually?
And y intercept.
Intercepts. X and y intercepts. So in this case, when x equals 0, so we're going to just go up here and we'll write intercepts as well. Intercepts. When x is 0, you get y equals 0. I think we can all see that. When y is 0, you'll get this. Factorize your x out. Don't forget you're in 2 unit. It's not a 3 unit question, so don't think polynomials. Factorize your x out. And then I'm pretty sure that becomes a perfect square. Yep. So x equals 0 and x equals -3 are my intercepts. So you can see it's just algebra again. The year 12 topics are not as hard as the year 11 topics. We'll see. All good? Then, back to this. Y dash. Y dash is 3x squared plus 12x plus 9. Y double dash is 6x plus 12. I just do that so it's added away and it's right on the top. You can always identify it if you need to. Y dash is equal to 0, so this guy equal to 0. Again, I can see we can divide by 3. So why not do it? X plus 3, x plus 1, x equals -3, x equals -1. Sub back in. Anyone done it yet?
0 and -4.
0 and -4. See, that's already interesting. Why? Because there was an intercept at -3. And now it's a stationary point. If it's an intercept and a stationary point, do you know what it's going to look like? An intercept and it's a stationary point. So it's either going to bounce on the x-axis or it's going to be a horizontal point of inflection. There's only 2 options you've got. It's either going to bounce on the x-axis, just like your normal routes. Remember, look, just wait, let's just recap something. Back in year 11, polynomials, you guys had to sketch this. And if you realize to sketch it, you factorize it, you got it to this. Doesn't this mean you're going to double root at -3, which means it bounces at -3 and it cuts through at 0? See? And that's what the stationary point is showing you. It's got a stationary point which bounces at -3. So you know you're doing it right at least. All right, I'll continue. Nature at -3, 0. Y double dash equals 6 times -3 is -18 plus 12 is -6, less than 0. max. At -1, -4. -6 plus 12 is 6, greater than 0, min. Which makes sense. You should have one max, one min, because in between there's going to be a point of inflection for them to meet, right? So far, any questions? Last bit, point of inflection. How do we find a point of inflection? Y double dash equals to 0. Again, what's the key word in point of inflection? It's a point. We've got to find x n of y, so don't forget that. So you go 6x plus 12 equals 0. X equals -2. Where am I going to sub back in? Because you have a lot of stuff now happening. To the normal one. You want to find y value, not y dash, not y double dash. All right, sub back into the normal. -8. Let's just do it. -8 plus 24 minus 18. -2. Apparently is what I got. Someone will tell us otherwise. Any questions? No, we're pretty happy with it. Now, here's the disclaimer. Every year I've got one student that slips through and unfortunately doesn't get the full marks in point of inflections. So you cannot stop there with point of inflections, no matter what the question says. Even if it says just if it's only worth 1 mark, you will get 0 if you just did that. So even if it's worth 1 mark, you will still get 0. So with points of inflections, you must prove it's a point of inflection. With stationary points, you don't. Stationary points, you just did the math, happy, done. The way we prove points of inflections is through a y double dash table. So I'll put it little here, must prove. I don't care if it's worth 1 mark. Don't come to me and say, oh, I forgot because it was only worth 1 mark. Too bad. You have to draw the table. Part of the working out. Even if your teachers tell you don't do it, you do it. Because then they'll deduct marks in your exams from doing it. Right? So don't listen. Or must prove, because I've heard that one before as well. Must prove x and y double dash, because it's the y double dash table. Why do I do y double dash? Because we're up to the y double dash section, right? Point of inflection is y double dashes. Stationary points was y dashes. Kind of makes sense, right? Y double dash, what's going to go in the middle? No back. What goes in the underneath it? Because obviously y double dash equals to 0 when x equals to -2. Good. Choose one before it, choose one after it, sub it back into where? Y double dash, because it's the y double dash table. Yes, not into y, not into y dash. See how this gets a bit convoluted a bit? Good. Sub it back into here. 6 times -3 is -18 plus 12 is -6. -6 plus 12 is 6. Okay. Order doesn't matter. So it's not like the one on top where we did nature and we realized it's slope to the left, 0, slope to the right, whatever. Order doesn't matter. We don't care about the order. We don't care about the number. All we care about is that there has to be a change. So it's going to be negative and it's going to be a positive. Why? Why? Why do we care just about that? Because what does that mean? What does y double dash less than 0 mean? No. Y double dash.
Oh, y dash, it's the max.
Max. Min. So something had to happen in between them. So since you're saying it's a maximum and a minimum, that means in between them there had to be a point of inflection. And that's a statement you're going to pretty much say. Here we go. Since change in concavity, since change in concavity, -2 is a, talk to your teacher about the POI. That one, I can't say. That just depends on your teacher. HSC, they'll accept it. Teachers, I don't know. Some do, some don't. So some think it's like point of intersection or whatever. So that's fair enough. Just talk to them, whatever they want, just do it. Point of inflection or PI. Done. That's everything. Except the sketching, which isn't that hard. That's it. It'll be 10 marks. So let's start from the top one last time. Y dash, Y double dash, stat points, Y dash equals 0, solve it, sub it back in to find your Y values. There's a point. Be aware of that. Nature. Observe your Y double dash or use your Y dash table to work out if it's a minimum or maximum. If you ever get, okay, so remember the question before we got equal to 0? If you get that, at this stage you will just be writing possible point of inflection. Then you're going to be doing what? Point of inflections. Y double dash equals to 0. If you've got the same point, which it should be, you'll have the same point, and then you're going to prove it. If it works, then you would say it's a horizontal point of inflection. If it doesn't work, which means there was no change in concavity, then you'll go back up here and you have to do it through the Y dash table. Okay, we'll see questions like that. And then you proved it, there was a change in concavity, done. Sketch a graph, 10 marks. I'm sure there's a HSC question coming up. Find any points of inflections. We'll leave that one as homework again, or soon to be classwork, I think. Let's just see what else. Oh, yep, that one will do. That's a good question. Example 14. Again, 100% will be in your exam. For what values of x is this concave up? What does concave up mean?
Minimum.
Minimum. What does minimum mean?
Y dash must be greater than 0.
Oh, so close. Double.
I meant double dash.
Yeah, I know, but that's what we all mean, right? This guy just said decreasing or increasing. You can't. You gotta be strict with it. Y double dash greater than, I know it's your first day, and I'm being pretty strict on it, but you have to be disciplined for yourself and be strict so that you don't mix this up straight away from the beginning. Yes, concave up, minimum, Y double dash greater than 0. Write it like that. Don't start the question. I didn't even care about the question. That was the key word. Those are the things I write. Now I can start. Y dash equals 9 x squared minus 8x plus 5. Y double dash equals 18x minus 8. This needs to be greater than 0. And because it's not a quadratic, I think it's pretty fair to say, I mean, I know this simplifies 4 over 9. Whatever, who cares? As long as x is greater than 4 over 9, it will always be a minimum. Always be concave up. Fair enough? Which obviously means if it was equal to 0, so if it was equal to 4 over 9, what would it be? If it was actually equal to 4 over 9. So at the top, y double dash would have equal to 0. What would it be? Y double dash equal to 0. It would be a point of inflection. Yeah? It's equal to 0, point of inflection. Greater than 0, minimum. So if it was equal to 4 over 9, it would be a point of inflection. If it was less than 4 over 9, it would probably be a maximum. See how that was the same number, just a different inequality sign. All right. Again, you can have a read of that. It's pretty self-explanatory. We're going to be doing it now. Okay. So the section I missed at the top. We're going to start a new file. You guys are also going to write this in spare paper or something. Write how to draw derivative graphs. How to draw derivative graphs. Now, I'm pretty sure some of you have done this in year 11. Your teachers would have introduced it in the year 11 concepts, which you shouldn't have been. You should have been in year 12, but whatever. How to draw derivative graphs. I do it differently. I didn't say that with the other ones, right? Because the whole world does it the same way. So all the stat points and stuff. It's just the way you set it out. I'll know if you're setting it out my way or if you're setting it out your teacher's ways. But this one here, I'm the only one probably in the world, that will do it this way because I made it up. So let's do it. How to draw derivative graphs. We're going to follow what I call ISP. ISP. Intercepts. What do you think S stands for?
Stationary points.
Stat points. And then P?
Points of inflection.
Point of inflection. Good work. The reason why I created this is because I needed to create something for Extension 2 students back before to be able to integrate graphs, and that was really complicated. And this works really well. So if we go up, it is differentiating. If we go down, it is integrating. Integration is next year. Right, but just so you know, if you're going to ever integrate a graph, we're going to read it downwards. For now, we're going to be differentiating graphs, how to draw derivative graphs. So technically, this is not just derivatives, it's also integral graphs, where you can technically integrate it. All right, so how do we read this? If we're going to read it up, that means points of inflections become stationary points. And then obviously stationary points become intercepts. Easy? And then you're going to hear one other thing that I'm going to say, which flows through from what we said in polynomials, and then that will link that topic, which is why I teach it that way. And it should be pretty easy. Your teachers don't do it that way. Your teachers look at it through slopes. So I think your teachers will be telling you this is negative slopes, so start from the bottom, positive, whatever. Different altogether. So it's got nothing to do with this. All right, let's start with the basic one. Obviously, what kind of graph is this? It's a parabola, which means we know that the derivative of this should be a line of some sort. Right? Let's see if it's true. Point of inflection. Do we have any points of inflections here? We're going to draw the derivative in blue. Do we have any points of inflections? Straight away, no. So that's nothing. There should be no stationary points. Do we have stationary points on the red graph? Yes, right at the bottom. Right here, there's a stationary point. What should that stationary point become? An intercept. What's so good about an intercept? You know the y value. What's the y value of an intercept? 0. So the good thing with intercepts is they're specifically, I'm not going to just do it on the origin for argument's sake, we'll just do it here, a little bit outside, just so you know that that's where the intercept is, it's not always at the origin. That becomes an intercept. And we actually know the y value of that. Sounds good? And then, from polynomials, which is, like I said, why I taught it that way, start top left. Where are we going to start? Starting top left. Where do we start, you reckon? Instead of starting at top left, bottom left. There we go, that rings a bell, doesn't it now? Remember for polynomials, if something started on the top left, we start in the opposite direction. For your even powered polynomials and negatives and so on. That's it, they're done. That's the derivative graph. Y, it's got one intercept, and start top left, we will start the opposite. If we're starting at the bottom left, what's the opposite of that? Top left. And that's it. Let's do another one. If there's no questions, we'll go to the next. ISP. We're going upwards for now. And I guess this time we'll write some numbers down. Let's write -3, -2, -1, and we'll write a half for the point of inflection, even though it's not here, it's probably here, but we'll just leave it as a half. That's 1, and that is 2. Okay. Just making it up, so don't worry if it's not too accurate. Okay. Again, what's the acronym? ISP. We're going upwards. The derivative. So, do we have a point of inflection anywhere on this thing? Yes, we do. It's at a half. So what do we know point of inflection needs to become? Now, you know it's stationary, but you don't know how high or how low. You just know it's stationary. You don't know the y value. And that's okay. So what we do, or what I usually do, is I just draw this. Something like that. So I know it's stationary. It's either going to be concave down, or it's going to be concave up. I don't know the y value. You could have drawn it here. Right? Don't ask me that. It doesn't matter. There is no y value. Cross it out. All good so far? Next one, stationary points. Oh, you love those ones because they become intercepts. So stationary becomes intercept. Stationary becomes. Oh, we're getting close. Now, last one. It starts at the bottom left, so we're going to start at the. Anyone think they know the answer? Parabola, and you can kind of see it. Look, it's going to bounce. So this was not relevant for us, but I put it in there just so you guys understand there's going to be stationary points. Good. Which makes sense a parabola. Why? Because it was a cubic in the first place, right? It had 3 roots. 1, 2, 3. Now it's got 2 roots. It had 2 turning points. Now it's got 1 turning point. So everything's making sense. Yes? Let's do a horizontal point of inflection. So that's a special case, and then we'll do an asymptote one, and then we're done. That's all the cases you're ever going to see. So let's do one with a horizontal point of inflection. Okay, let's do that one. Okay, ISP. Make a note. With a horizontal point of inflection, horizontal point of inflection becomes both stationary and intercept. Why? Because for it to be a horizontal point of inflection, wasn't it that y dash was equal to 0 and y double dash was equal to 0? Wasn't that kind of what happened? Because we realized that y dash equals to 0, we said it was a possible point of inflection. And we have to go and prove it here. So both of these are equal to 0. So technically it is stationary and it is a point of inflection, which means it will eventually become, when you move from a point of inflection, it will become stationary, but then the stationary will become an intercept. So horizontal point of inflection is both stationary and intercept, but in other words, it is, if you want in like the words you probably remember, bouncy at the, or on the x-axis. It's bouncy on the x-axis. So it's specifically, you know how, come up here, see how this one here, I said it's a point of inflection, but I said, oh, I don't know how high or how low to go. This one, it is a point of inflection, but because it's horizontal, we actually know the y value. It's on the x-axis, and that's why it's an intercept. So it's actually bouncing on here. So it's not in midair somewhere. That's the only difference between the two. Now, I haven't had many students that remember this case, because most of the questions you're going to see in your textbooks are based off this case. So please, make a note of that. It's an important one. All right. Otherwise, let's get our blue one out. Let's get started. The one I like starting with is stationary points because they give you an intercept. So that's stationary there. So that's an intercept right there. Done. This one here, we know it's a horizontal point of inflection now, so we understand it's going to look like this or like this, one or the other. Again, but because we know the y value now. Now, this is the one that everyone misses. Increasing, sorry, let's not talk about increasing, let's talk about happies and sads. So is this happy or sad here? Sad, then it becomes, at this stage, it's becoming what? Happy. And then what happened again? So what needs to happen right here? Oh, it needs to become a stationary point, sorry. So what is it at that point? It's a point of inflection. Everyone misses that one there. That is a point of inflection right now, so therefore it will become a stationary point. So again, it'll be like this or like this. See how these two will connect? Or it's these two that will connect. Now, I do say this to students. I go, look, if you did ever forget that, right? If you did forget this and you only had these two and you somehow remembered the horizontal point of inflection, it's okay. You would have started from where? Top left, right? So you would have started, you would have bounced, and then you would have realized, wait, what? I need to somehow get to here. So then you would have realized, oh, I needed to have another turning point. It needed to happen. And then you would have realized, oh, yes, I missed the point of inflection there. And that's fine. No one's going to penalize you on that. No one will know. And that's the answer. So you don't go all the way up to this blue stationary point, right? That's a direction for you. Just trying to tell you it's a stationary point there. We're happy with that? That's very, very different to your teacher's technique. This is meant to be the proper way, right? You really know it, like this is really the way you should be doing derivative graphs. But anyways, it is what it is. Last one is, what if I had an asymptote? So I think let's combine everything. Let's do a horizontal point of inflection with an asymptote case, and then you guys can just rest assured you'll be fine, no matter what question you get. All right, let's go with -10. So look to the one we were doing above, and the only difference between the two is this one went forever, this one's actually coming back and approaching -10. All right, one last time. ISP. We're going up for graphs. The reason why I keep emphasizing that is because obviously in your head you might be thinking we're going down, y dash, y double dash. Because I made this thing up, it's not obviously flawless, so we're going up, just be careful. All right, point of inflection, this guy here. I think we now know it's going to be like that, going to be like that. That's a stationary point, so that's an intercept. What else do we have? Can we see that that's a point of inflection there? So again, that needs to be a stationary. So then let's follow it. But just always tell yourself increasing or happies and sads. Like use those words. So like this one, we're going to go sad, 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 sad. And then something needed to happen for this to not go sad anymore. It's starting to become happy. So that must be another point of inflection. So another one here. See? Again, people miss that. Just run through the whole graph, like sad, 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 happy, 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 happy. Wait, what? Sad, sad. So then point of inflection, sad, sad, sad. Wait, what happened here again? How come that's moving? Okay, another point of inflection. Like you'll pick it up. Don't make it harder than that. I'm making it very simple. Okay, start at the top left. I think we got it. We're going to go here. We're going to go up. We're going to come back down. We're going to cut through this guy. So far looking good. We're going to come back up. We're going to come back up. We're going to come back up. This guy's telling me go up. Now is the problem with this asymptote. What's going to happen if I just draw this? What is a problem that I will have if I just draw that? Okay, if you can't see it, well, what's the problem with this? Specifically there. What's that called again? An intercept. What needed to happen for you to have an intercept? You needed to have a stationary point in the original one for it to become an intercept. Does this look like it's a stationary point anywhere here? No, so you cannot have an intercept. That's all. If you can't have an intercept, what are you going to do? Make it approach 0. You can't cut through. Not allowed. And that's it. That's all you're going to do with the asymptotes. So they're not that hard. They just require you to just pause for a second and go, wait, I can't have an intercept then. And yes, that's a point of inflection and blah, blah, blah. Can you see that? Like that's happy and then, that's not your worry. You can't tell where a point of inflection is going to occur. Right? That's not going to, it's not going to show you that. Also, you don't care about what intercepts are. So intercepts don't become anything else. So don't look at intercepts and go, okay, what do I do with intercepts? You ignore them. You're only looking at points of inflection and inflection. Done? All right. Any questions? I think we'll go back to, I think it was like page 3 or something. So let's go right at the top. And now, this one right here, page 4. Page 4. HSC question. 4 marks. All right. The diagram shows the graph of a function. Y equals f of x. For which values of x is y dash negative? So what does that mean again? Let's just use the words we're used to by now. Y dash negative means y dash less smaller than 0, which means wait, no, don't say that one. Just tell me what the word is that I'm looking for. Y dash less than 0, that's the word I'm looking for first. Decreasing. Because if you can say that word, then you might realize, wait, hold on, this is increasing for me now. See what I mean? So just use that word. Now, where is it decreasing? Well, I think you guys get the idea. So where is it decreasing now, Novak? Including -1 and 3? No, why not? Because it's stationary. Good work. So you write that, or obviously up to you guys. If you're using your interval notation, you can write that there. On the Done? Double I. What happens to y dash for large x values? What happens to y dash for large x values? Well, this is like when I taught you guys inverse trig functions. I said, don't do double I if it's getting confusing like that. Do triple I first. Let's sketch it. And then once we've sketched it, we'll know what's happening to for large x values. Right? So open up your eyes. Don't always just be stuck on double I. Go on to triple I or IV if you can. Sometimes they're easier. And then you come back and do double I. All right. Sketch the graph of y dash. ISP going up. We're differentiating. Stationary point becomes an intercept. So beautiful and beautiful. Point of inflection, probably that one there. That becomes stationary there and there. And that's happy. And another one here, right? There's another point of inflection there. Anyone have any questions before I pretty much finalize this? No? All right. Start on the top left. Cut through, cut through, cut through. Bounce. Cut through. Bounce. Again, I have the same problem I had before. What happens if I just do that? It shows me that I've got another intercept which I didn't have. And then I think you just answer double I. What happens to f dash of x for large values of x? What's happening to the graph? As x is getting larger and larger, the graph is getting What's this approaching?
Approaching zero.
Approaching 0. Isn't it? It's getting smaller and smaller. The graph is getting smaller and smaller as x is getting larger and larger. So f dash x approaches 0. Done. See how much easier it was to do double line once you've got triple line? It's okay to do that. Learn to do it. You guys get so used to it. I guess it's because the way you've been conditioned from like lower high school and so on. You know, always do things in order. But be flexible now. Done. 4 marks. Nice and simple. Let's go back. Finish off these last few, and then I'll get you guys working. This one's next week, I know that. Next week, which again, I've got to talk about. But example 15. Have a read of it. How are we going to time? Yeah, perfect. On time. By inspection of the graph of the function, answer the questions below. Okay, evaluate f of 0. What does f of 0 mean? X is 0. What does that mean? When does that occur? When x is 0? F of 0 is your y-intercept, which is 6. Looks fancy. Solve, obviously you guys can see it's an exam question, right? It's worth 6 marks. Solve f of x greater than 0. What does that mean now? F of x, not f dash, not f double dash. What does f of x greater than 0 mean? That's f dash. F of x, that means the function. The function is greater than 0. When will the function itself always be greater than 0? When is the y value greater than 0, pretty much?
And it's increasing.
No, you said increasing as well. That's y dash.
So when's the graph positive?
Yeah, when's the graph positive? The graph is positive all here.
Yeah.
Before 10. X is smaller than 10. You see that now? Where's the graph positive? It doesn't say dash. You can't say increasing and decreasing. You only say increasing, decreasing when we say f dash. You say maximum, minimums, or concave up or down, whatever you want, when we say f double dash. Like the next one. Mark a point A on the curve where y dash equals 0. What does that mean? So let's write it. SP. And y double dash less than 0. What does that mean?
Max.
Max. You write it. Don't look at it like a whole bunch of letters and numbers and stuff. Just actually write those things down. Where is it a maximum stationary point? Where do you have a maximum stationary point? Right here. Isn't that a maximum stationary point? Is it? It is, isn't it? Mark a point B on the curve where y dash and y double dash have opposite signs. That usually gets everybody because they're like, well, what's opposite signs mean? Or what does opposite signs mean, Novak?
Negative or positive.
That's it, as long as one's negative, one's positive. Does the order matter? They're trying to tell you we don't care. Just pick one, that's positive and negative. You pick. What do you want? Y dash, negative or positive?
Negative.
Negative, so we're going to go for this one's less than 0 and this one's greater than 0. What does y dash less than 0 mean?
It's decreasing.
Yeah, we go, we're getting it. Decreasing. Y dash greater, y double dash greater than 0. Minimum. So we're looking for a minimum where it's decreasing. All right, here's a minimum. Yes. Where is it decreasing? That's increasing. That's 0. That is decreasing. So point B, let's put it right there. Put B. You can put it anywhere on that section, but you get it? Happy? C. C is a point on the curve where the concavity changes from concave down to concave up, Mark the point C on the curve. Where is the curve concave down to concave up? Let's have a look. That's concave down only. That's concave up to concave down. That's not the one we're looking for. That's up to down. There it is, isn't it? It's hidden right there. Let's look at it one more time. That's concave down. Look. Stop. What happens right there? Concave up. Concave down. Concave up. That's C. And obviously, what do you know about C? What should C be? Which of the following is true about C? Y double dash less than 0, Y double dash equals 0, Y double dash greater than 0. What would you say is C? Why is it equal to 0? Because it is the point where it changes from concave down to concave up, or vice versa. All good? Okay, next one. I might just leave you guys with this one for a few minutes again. Just have a think. Don't overcomplicate it, but put down things like write, SP or increasing, decreasing, whatever. Next page. Think of it. Okay, let's have a look at it together. Y dash equals to 0, that means stationary point. Y double dash less than 0 means max. Where do we have a maximum stationary point again? I think that is C. Bye-bye, thank you. I'll work it out. Okay, thank you. See you. C. All right, next one. Y dash equals to 0 and Y double dash equals to 0. That means it is a stationary point and a point of inflection. Stationary point and a point of inflection, which in other words is a horizontal, because it's stationary, and then point of inflection. Where does that occur? E. Triple I. Only 2 students got it right on Thursday. Y dash less than 0. What does that mean?
On the left-hand side.
Decreasing.
Decreasing.
Decreasing. Y double dash greater than 0. Minimum. So we want the point where it is a minimum and specifically decreasing. Most students went for A. It's incorrect because that is a minimum and it's stationary, not decreasing. Right there. That is a minimum, and it is decreasing still. It's D. Did you get that out? Ooh. Number 3. Did you get it out? No, A. All right, last one. Y dash greater than 0. It's increasing, and f of x is greater than 0. What does f of x greater than 0 mean again? The graph is above 0. So where is the graph above 0? And it's increasing. B. Right there. It's increasing, and the graph is above 0. Sounds good? All right. Write down the set of values of x for which it is an increasing function. All right. When is it increasing? Let's have a look. This is decreasing, decreasing, decreasing. I think it's increasing from here all the way up to here. And then this is all decreasing, isn't it? Yep. So how do we write that? From -2 all the way up to 3. That was easy. Last, for what values of x is the curve concave up? Curve concave up. Rub, 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 rub. When is the curve concave up? It's concave up here. Happy, 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 happy. Stops being happy. And then it becomes sad. Wait. And then what happens here? Also changes and becomes concave up. So it's the numbers from 5 to 8 and less than 2/3. So x less than 2/3 and between 5 and 8. X less than 2/3, x between 5 and 8. Easy? Done? Done. All right. Example 21. You guys are done. There's nothing new to learn. So, pretty much it's just a sketch indicating all critical points. You're going to do y dash, y double dash, find stat points, which is y dash equals 0, find the nature, using whichever technique you like, do your points of inflections through y double dash equals 0, don't forget to prove it, and then sketch. I'll leave it with you, 10 marks. We're done. I don't think we need this recorded anymore.